physics for class 7 and the topic is measurement. And today we will be doing numericals related to density. So you know, last time we discussed about density, we discussed what is density, and we did one numerical as well, isn't it? So what I checked is there are other numericals related to it. So we'll be doing 3-4 sums today. Okay, so and everything, all the sums are based on the same relationship, that is density is equal to mass divided by volume. Okay, you need to remember this. The formula for density is mass divided by volume. So how is density defined as? Density is defined as mass per unit volume. Okay, so we'll be doing numerical, which is in your book, page number 27. Page number 27. Question number I. Sub-question number 5. Okay, sub-question number 5. An object has volume 3 cubic meter and density 6000 kilogram per cubic meter. What is its mass? So far in the last class we did how to calculate density when mass and volume are given. Today we will be calculating how mass and volume are given if density and mass is given or density and volume is given. Okay, so question number 5, the first one we need to write down whatever is given. So volume is given, and how much is the volume given? Volume is given as 3 cubic meter. Okay, volume is given as 3 cubic meter. What else is given? Density. And how much is your density? 6000 kg per cubic meter. Okay, the volume is given as 6000 kg per cubic meter. You need to calculate its mass. Okay, so we'll use this relationship. Density is mass by volume. Therefore, when you are calculating mass, if you are calculating mass, this volume and density is given, and if you have to calculate mass, so what you need to do is you need to take volume this side. Okay, so when volume goes to this side, volume is in the division form. When it changes its place, it becomes in the product form. So when you have to calculate mass, you have to multiply density and volume. So if you are ever calculating mass, if density and volume are given, so what you need to do? You simply need to find the product of density and volume. Now, second thing that you need to remember is the unit. What is the unit here? Cubic meter. What is the density given in kg per cubic meter? That means all the units are SI units. So we don't need to change anything over here. Okay, we don't need to do any conversion here. So we can simply put the values and simplify. So how much is the density? Density is 6000 kg per cubic meter. And how much is your volume given? Volume is given as 3000 cubic meter. So when you find the product, how much do you get? 18,000. And what is the unit of mass? The unit of mass is kg. So what is your mass here? Mass is 18,000 kg. So you can just quickly revise, you can just see here, according to the question, volume is given, density is given. What are you supposed to calculate? Mass. Okay, using the relationship of density, mass and volume. So what do we get from, how do we calculate mass? Mass is equal to product of density and volume. So you simply have to multiply density and volume. And all you need to do is put the values. So what is the value of density? 6000 kg per cubic meter. Volume is 3 meter cube. Simply multiplication. So we get this much, 18,000 kg. Okay, so this would be your mass. Okay, this is how you calculate mass. Okay, question number 6. Calculate and complete this table is exactly like you all can do. So I'll move on to another question. and that question would be question number 8. Okay, 7 is exactly similar to question number 5 actually, but you might be confused a little bit regarding the volume, because the question says number 7. I'm talking about question number 7, page number 28. A water tank measures 2 meter into 4 meter into 5 meter. What mass of water can it contain? Density of water is 1000 kg per cubic meter. So density is given, you need to calculate mass. So when density is given and if you have to calculate mass, what else do you require? Volume, isn't it? You need to find volume. And instead of volume, what is given here? Length, breadth and height. And in this chapter itself, in the beginning itself, we learned how to calculate the volume, isn't it? So what is the formula for volume? Length into breadth into height. So here you simply have to multiply 2 into 4 into 5. Okay, you only have to multiply 2 into 4 into 5, and whatever you get is your volume actually. That would be your volume. So I think you can try it on your own, question number 7, and I'll be doing question number 8 on the board. Okay, question number 8 reads, an object has a mass of 20,000 kilogram and a density of 4,000 kilogram per cubic meter. What is its volume? So here, question number 8, what is given? Mass, which is 20,000 kilogram, and density, which is 4,000 kilogram per cubic meter. And what are you supposed to calculate? Volume. Okay. So instead of volume, in question number 8, instead of volume, mass is given. And how much is the mass given? The mass is given as 20,000 kilogram. Density is given, which is equal to 4,000 kg per cubic meter. Use the same relation, density is equal to mass by volume. So instead of mass, what are we supposed to calculate here? Volume. Now if we are calculating volume, then the formula changes to mass divided by density. Now see this relation. We are just interchanging the position of volume and density. So volume goes this side, density comes down. Because we are calculating volume, therefore volume goes here, density comes down. So mass divided by density. And how much is your mass? Your mass is 20,000. And how much is the density given as? 4,000. This is kg per cubic meter. So do the cancellation, 3 zeros and 3 zeros cancel. For how many times 20? 5. So what is volume? Volume is 5. And what is the SI unit of volume? The SI unit of volume is cubic meter or meter cube. So how much is your volume? Your volume is 5 cubic meter or 5 meter cube. So this is how we calculate volume. If density and mass is given, and in question number 5 we learn how to calculate mass if density and volume are given. Okay, question number 9 is similar to question number 7. Question number 9 says the density of air is 1.3 kg per cubic meter. What mass of air is contained in a room measuring 2.5 meter into 4 meter into 10 meter. So density is given, you have to calculate mass. So what else do you require? Volume. And in order to calculate volume, the length, breadth and height is given. You simply have to multiply. Volume is equal to 2.5, that's length into breadth into height. That is 2.5 meter into 4 meter into 10 meter. Multiply and then you get the volume. After you get the volume, calculate the mass. Exactly like question number 5. Okay. So further we'll be discussing about relative density. Okay. So we did numericals. I hope you understood this one, and I hope this was quite clear with you people. I hope you understood how to calculate. Now you know how to calculate mass, volume and density if either of them are given. Now, the next one we'll be discussing today is relative density. So, the word relative is comes from, relative means something related to, isn't it? So then when we talk about relative density also, we are relating the densities here. Okay, so we compare the density of a substance to the density of water, because the density of water is always fixed. So we compare it with the density of water, and not at any temperature. Okay, density of water at 4 degrees Celsius, which is 1 gram per cubic centimeter in CGS units and 1000 kilogram per cubic meter in SI unit. So density of water is fixed at 4 degrees Celsius. So it could be either 1 gram per cubic centimeter or 1000 kg per cubic meter. The relative density. The comparison of densities of most of the substance with the density of water at 4 degrees Celsius helps us to memorize the density of substance. So this comparative value of the substance is called relative density of the substance. So how do you define relative density? Relative density is defined as the ratio of the density of a substance to the density of water at 4 degrees Celsius. Okay, so how do you define relative density? It is defined as, it is a ratio of density of any substance. Okay, it can be any substance, density of a substance to the density of water, and not at any temperature but at 4 degrees Celsius, because at 4 degrees Celsius density of water is 1 gram per cubic centimeter or 1000 kg per cubic meter. So if you are comparing in CGS, you take 1 gram per cubic centimeter. If you are taking in SI unit, you take it as 1000 kg per cubic meter. Okay, so when we are comparing the density of a substance to the density of water at 4 degrees Celsius, we call it relative density. And since this relative density is a ratio, okay, since relative density is a ratio, it's a pure number, so it will not have any unit. A relative density does not have unit. Okay, it has no unit. It does not have unit. So relative density does not have unit. Okay, so it is unitless, unlike density. And the instrument used for measuring, relative density is called relative density bottle. Okay, and it's made up of glass which has stopper. So you have it in the picture in page number 23, figure 1.17. If you are referring to your book, that is the picture of relative density bottle. Okay. Now the last part of this chapter is effect of temperature on density. So how does temperature affect density? If there is increase in temperature, what happens is the kinetic energy of the particle increases and the particle starts moving apart. So when the particle starts moving apart, the volume increases. So if the volume increases, what happens to the density? If volume increases, then the density will decrease. So how does temperature affect density? With increase in temperature, density decreases. Okay, so they are indirectly related. If temperature increases, density decreases. And why does it happen? It happens because when temperature increases, the particles, the kinetic energy of the particles increases. The particles starts moving very fast. And when the particles start moving fast, they tend to break the intermolecular force of attraction. Okay, and the intermolecular space between the particle increases. And when the particle starts moving apart, then they occupy more space. And when they occupy more space means they have more volume. And when volume increases, density will decrease. We discussed that in the beginning itself, isn't it? So that is the effect of temperature on density. Okay, so with this we conclude the chapter, and regarding the question and answer, I'll be giving it to your respective class teachers. So if you have any further doubt, please do ask me. Thank you and have a good day.